Hello everyone. Today I'm gonna introduce you to a physical model called mass and spring system with damping. The reason why we chose this topic as our final project topic is that it has lots of applications. And the picture to the right is its simplified model. The F denotes the force caused by the gravitation and is always pointing downwards, and the Fs denotes the force caused by the spring. When the object is below its original point, meaning the spring is pulling back, thus Fs is acting upwards. And if the object is above its original point, meaning that the spring is pushing the object downwards, thus the Fs will be pointing downwards. And except for these two F and Fs forces, there are often the third force called the damping force, and it is often caused by frictions, fluid resistance like oil damper we will introduce later, and lots of other factors. So it is quite uneasy to measure. And because it's so uneasy to measure, we often assume that Fd is proportional to the speed of the object, but in opposite directions. Meaning that if the object is moving downwards, the damping force will be acting upwards. And if the object is acting upwards, the damping force will be acting downwards. Thus, the damping force is always dissipating the energy of the object, thus making its oscillation less and less. And by assuming Fd is proportional to the speed of the object, we can reduce the replacement of the object, the equation, to a second order non-homogeneous differential equation. Thus, by using those methods we learned from class, we can solve for either the object's replacement or its speed. And as I said, it has lots of applications. The most well-known one will probably be the two-mass damper in Taipei 101. It uses cables to attach the giant ball to the 92nd floor, and it has 16 oil dampers attached to the giant ball. When the building suffers from a strong wind or earthquake, because of the ball's constant, it moves to the opposite direction of the building. If the building moves to the right, the ball moves relatively to the left, relatively to the building. And because of the oil damper, the oscillation of the ball became less intense. Thus, we can stabilize the building and make the people there feel better, feel less unease. The second application will be the shock absorber of motorcycles or cars. When a motorcycle runs into a bump, the spring in the shock absorber is compressed, and the damper inside of it will dissipate the energy and make the spring become pressed less intensely and make the driver feel less jumping, feel more comfortable. And when the spring bounces back, the damper also absorbs energy and prevent the spring from bouncing back too quickly and make the driver more comfortable while riding a motorcycle or driving a car.